This may very well be the first problem that is introduced to a high school student for two-dimensional kinematics. Though it appears complex, it is really made up of two simple one-dimensional problems. I am going to explain the concept through these animations so that you do not forget. So let's begin with the problem. Pause the video so that you can read the problem and understand. Let me proceed. The situation is the plane is at an altitude of 900 meters. It is traveling with a horizontal velocity 200 meters per second. The bomb is dropped, which means vertical velocity of the bomb is 0. And we need to calculate the horizontal distance so that it hits the intended target. We firstly convert the verbal questions to mathematics, which means as variable that is given and what is asked. Once done, we never want to read the question again. In this question, along the horizontal direction, we are given the initial velocity of the plane, which is 200 meters per second. We have no acceleration along x, and d is the horizontal displacement, which is being asked in the problem. In the vertical direction, initial velocity is 0 because the bomb is dropped and not pushed. The altitude displacement is written as h is minus 900 meters. It is negative because positive is considered up and the bomb is falling down. G is minus 9.8 meter per second square. It is also negative because acceleration is downwards. And as I said, positive is up. That is all which is given and asked. Just one more comment. Don't get scared by the symbols Vxi, Vyi. It is only for clarification that the velocity is initial and it is along x or y direction. Now let us remember the three equations of motion. We hope you are good at solving one-dimensional problem. Now let us see how we solve the problem. Here is a fun animation of the plane dropping the bomb. Let me begin the animation. Note that the position of the plane and the bomb is exactly the same in horizontal direction. So it means that in horizontal direction, the equation that we used for plane can be also used for the bomb. Let us now do some mathematics. Here we need to find d, the horizontal distance from the moment the bomb was released from the plane to the moment the bomb falls to the ground. We rewrite the given and asked condition in horizontal direction that we did earlier. We use second equation of motion to get the d. Since the acceleration is 0, we are left with distance is equal to initial velocity times time. But wait, we do not know the time it took for the bomb from dropping to hitting the target. To find this time, we will have to see the same event of dropping the bomb in vertical direction. Let us see that and then figure it out. Here is another fun animation of the plane dropping the bomb, but the focus will be on the vertical direction. On the left is the ball at the same height as that of the plane. The ball will be dropped at the same time when the bomb is dropped, and we will compare the ball and the bomb's vertical position. Let us begin the animation. Note that the position of the ball and the bomb is exactly same in vertical direction. So it means that in vertical direction, the equation we use for the ball and that of the bomb is the same. So let us do some mathematics. We rewrite the given information of vertical direction, but the intention is to calculate the time t. It is a simple one-dimension problem, exactly the same as dropping of the ball. Let us solve. Again, the second equation of motion comes to the rescue. Here, the initial velocity is zero because the bomb is dropped, and the acceleration is acceleration due to gravity. We substitute these values and are able to get a time t equals to 13.55. We substitute in the previous equation with d and we are done. Let us summarize again. We bring all things together in this one slide. We saw in horizontal direction the bomb has a constant speed just like the plane. It was easy one-dimensional motion and d comes out to be 200 times d. In vertical direction, bomb behaves just like dropping of a ball in one-dimensional motion. We used second equation of motion to solve for time and get 13.6 seconds. We substitute this time and get the answer for D, which is evaluated to be 272 meters. So the plane need to drop 272 meters before the target so it can hit the intended target. I hope you have learned a good deal in this video. To never forget. Bye bye.